So a volume of solid generated by revolving a region bounded by the two curves of y equal to fx and y equal to gx. So look at this one here now. To find the area of this, we need to find the intersection point between this and this. Okay. And previous knowledge of to find the area between these two curves here, we come up with A equal to integral of, okay, this graph is above the gx. So then fx minus gx dx. But before that, before we substitute variable of x from a to b, we need to find out the intersection point here by come up with fx equal to gx until we get x1 equal to a and x2 equal to b. Okay. So then, to find the volume, there's still here pi integral of, okay, to be careful here, is fx squared minus gx squared. Okay, sometimes students come up with this from a until b, fx minus gx squared dx, which is totally wrong. So please be careful that the square, okay, for the function 1 by 1. Okay, and also here, whether we call revolving by the two curves of y equal to fx about the y-axis. Okay, he rotated to the x-axis here. And this is it. And this is it, the volume. I'll put the formula of the volume here. The region bounded by the curve y equal to square root of x and y equal to x cubed. Find the volume of solid generated by revolving through the x-axis and y-axis. Okay. Y x. Okay, so this one, y equal to square root of x. I sketch with a, we call color of the blue ink here, and then y equal to x cubed. There you go. This is y equal to x cubed, and the blue ink color graph here represent y equal to square root of x. So there is an area between these two curves, the blue curve and the purple curve here. There's an area bounded by these two. Okay, just imagine that this area rotated 360 degrees to the x-axis or might be to the y-axis. So if I sketch through the y-axis here, it is something like this. Okay, rotated 360 degrees to the y-axis. Okay. And so on. You may try, okay, sketch the graph of the, we call the shadow of this on the y-axis here below here, and then rotated 360 degrees to the x-axis. Okay, so now V1 means that the volume rotated to the x-axis here equal to pi integral of which graph? The graph y equal to square root of x is above. So square root of x square minus, and the graph below here which is y equal to x cubed square Okay, pi from, okay, now we need to find the intersection of this. In this case, okay, which I think that we discussed this in our previous lecture of the to find the area, which is y1 equal to y2 square root of x equal to x cubed. So to terminate this square root of sign here, come up with square left and right. So then x equal to x power of 6. So then x6 minus x equal to 0. Then x minus power of 5 minus 1 equal to 0. Then x equal to 1 and x equal to 0. 1 here. Okay, so then now pi between this and this, from 0 until 1. From 0 until 1, terminate between this square sign and square, come up with an x here, and then this one, x to the power of 6 dx. Pi, and integrate x squared divided by 2 minus x 7 divided by 7 from 0 until 1. So then here pi, substitute 1 here, 1 over 2, 1 squared is 1 over 2, minus 1 power of 7, still 1 over 7, and minus 0 and 0, everything 0. Okay, so then here now, what can you see here now? It is pi 1 over 2 minus 1 over 7, make it 1 over 14. 2 times 7 and 1 times 7, 7 minus 2, which is equal to 5 over 14 pi unit cube. Okay, I think that I'm going to clear this off. And volume 2, which is pi integral of, okay, now again here, what about this one here? X equal to 1. So when x equal to 1, 1 cube equal to 1. Okay, we have found the intersection point between these two curves and found that x equal to 1. Substitute x1 into this one, into this function equation here. 1. 1 cube also equal to 1, means that y also equal to 1. Okay, look at this graph now. To the y-axis. To the y-axis, the graph in purple in color here is above and the blue is below to the y-axis. So then, in this case, come up with x cubed squared minus square root of x squared dy. Okay, respect to the y, which I think that we need to make some adjustment here. Okay, it's not it. Okay, sorry. V equal to pi integral of y equal to square root of x. Change this into the form of x equal to the function of y. So x, if I square here, then also square here, x equal to y squared. Am I right? Y equal to square root of x. So the square, left and right. There you go, x equal to y squared. And then what about this one here now? Y equal to x cubed times 1 over 3 here and 1 over 3. then x equal to y to the power of 1 over 3. So this curve of y equal to x cubed, in the function in the form of x equal to fy, it is y over 3 here, because this curve above this to the y-axis. Okay, so it is y power of 1 over 3 square minus, and this one here now, it is y square dy. Okay, then by integral this from 0 until 1, and here now y 1 over 3 times 2, 2 over 3 minus y power of 4 dy. Okay, pi. Then integral of y of 2 over 3, so 2 over 3 plus 1, or 2 over 3 plus 3 over 3, which is 5 over 3 divided by 5 over 3, or switch the position upside down, it becomes 3 over 5. And minus integral of y power 4 dy, y power 5 divided by 5, from 0 until 1. Okay, as usual, we substitute the value of y 1 first. Okay, 1 and 0, which I think that is all easy. Y power of whatever equal to 1. 1 power of 5 over 3 is still 1, so 3 over 5 minus y 1 power of 5 is still 1 over 5 minus 0 and 0. So then 5, and here 3 minus 1 of 5 and 5, 3 minus 1, which is 2 over 5 pi unit cube. Okay, so 2 over 5 pi unit cube.